Okay, so let's look at how the equations for translating the absolute value function work. So I've got a slider here, and it lets me translate my absolute value function. So in red, I have y equals the absolute value of x, and in blue, I have y equals the absolute value of x plus a. You'll notice here the plus is outside of the absolute value symbols, and that's important. And as I make a bigger and bigger positive numbers, my graph moves farther and farther up. So if a is 3, so if I have y equals the absolute value of x plus a, then my graph, my blue graph, the vertex is translated up to the point 0, 3. Which means that it is translated up 3 units. So plus 3 is translated up 3 units. If I make that negative, then I'd be dealing with like x minus 3. Now you can see I have translated down 3 units. So plus translates up and minus translates down. And whatever the number is, that's how far you go. So let's look at this. So here, what we have to do is we have to graph a vertical translation. What is the graph of y equals absolute value of x plus 2? Well, this plus 2 tells me that it's going to be translated up 2 units. So normally, my vertex would be at the origin, but now I'm going up 2 units, so my vertex is going to be at positive 2. I'll just very lightly draw in here the parent function. And the translation here is that my function has been moved up 2. Now, when you draw the absolute value function, it has a slope of 1. So you basically just go straight diagonal across all of the grid squares. So you get a slope of 1, and on the other side a slope of negative 1. So it just goes through all of those grid line intersections. And there in blue, I have done exactly what I needed to do. I have made the graph of y equals the absolute value of x plus 2 just by drawing the absolute value function and translate it up 2 units with the vertex at 2 and the slope from there of positive 1 and negative 1. If we were asked, what is the graph of, I wonder if I can make that bigger. Woo! What is the graph of absolute value of x minus 7? Well, that minus 7 would mean we'd be going down from the origin, down 7 units. And so, from here, we'd have to go down all the way down off the graph here to negative 7, and then draw our graph down there. Be careful when you draw this. You want to draw the slope correctly. So it's hard for me to do down here because I'm off the graph, but when you're on the graph, which you will be for yours, it's just going through each of those grid line intersections. Okay. So here's the ones you're going to do. You can see you've got nice big graphs that will easily hold your function. You don't have to necessarily go all the way. So like if you were drawing your line, You could draw it part of the way and then draw an arrow if you want. Or you can draw it all the way to the edge of the graph, whatever you like. Okay, so graph those. Be careful about how they are being translated. So -3, +7, +3. Get the vertex in the right spot. And after that, we'll look at like graphing horizontal translations and then composites of both vertical and horizontal. All right, good luck with those. I'll see you in the next video.